Okay, so let's do a Chapter 8 review problem. It's another multi-part problem. It's Chapter 8, number 8. This is the upper leg length of an adult male is approximately normal with a mean of 43.7 centimeters and a standard deviation of 4.2 centimeters. Question A is, what is the probability a single male's leg length is less than 40 centimeters? This is really a question that lends itself to Chapter 7. We just find the z-score, so that would be 40 minus 43.7 over 4.2. That's negative 3.7 over 4.2. As a z-score, that is negative 0.88. So we go to our z-table and find the area to the left of the negative 0.88. So to do that, we look for negative 0.88. I show 0.1894. It's, I want to say 0.1894. So that is the chance of a single person's leg being less than 40 centimeters. Stubby legs. We don't make fun of people with stubby legs. Now, suppose a sample of 9 males is obtained. What does the sample mean in standard deviation? So the sample mean never changes. It's exactly the same as it was before. You expect the mean to be the same regardless of how big your sample is. However, the standard deviation, you have to take your standard deviation and divide it by the square root of your sample size. So in that case, that's 9. Well, what is the square root of 9? 3. So you have to take 4.2 and divide it by 3, which is 1.4 centimeters. Why is that? Because if you're finding the mean of 9 people's leg lengths, the more people you have, long legs and short legs start offsetting each other, so you should get closer and closer to the actual number. So while one person can have an outlier relatively easily, more people's average can't have an outlier nearly as easily. Now, what is the probability of a sample of 9 male legs has a leg length less than 40? This is exact same as A, but instead of using A's standard deviation, we now have to use the group standard deviation. So it's 40 minus 43.7 over now 1.4 instead. So that's negative 3.7 over 1.4. Let's see what that is. It is negative 2.64. Okay, so now same thing we did before. But instead, we're now looking for negative 2.64 in our z-table. That is very small. I show it as 0.0041. So when we're looking at question D, it says, what effect does the increased sample size have on the probability? They're really asking you to compare part A to part C. Part A's probability was about 19%. Part C's probability was less than 1%. So what did the sample size increase actually do? It reduces the probability. I mean, that's it. It just reduces the probability of having a mean length, an outlier as an average. I don't know why I just didn't write that in the actual lines, but it's fine. We'll live. So a random sample of 15 males has a mean 46 centimeter legs. So those are larger than normal. Is this unusual and why? So we still have the average of 43.7, but my standard deviation now, instead of dividing by the square root of 9, we now have to divide by the square root of 15, And I would just put that in the calculator because it's not a perfect square. 4.2 divided by the square root of 15 is 1.08. I'm going to carry this a few decimal places. We'll go 4. So to calculate my z-score here, I'm going to have to take 46 minus 43.7 over 1.0844. I get a z-score of 2.12. Now, generally speaking, if they ask you if it's unusual or not, if it's more than 2 standard deviations away, so either more than positive 2 or less than negative 2, then it's unusual. Why? So is this unusual if we got 2.12? Yes, because it's more than 2 standard deviations away. And that is an example of one from Chapter 8. We'll do 9 next.